there it was, I gave explanation. I'll further clarify things. This is a refracted ray. This is the medium one, mu1. Here the light will propagate with the speed v1. Refractive index mu2, light will propagate with the speed v2. Wavelength of light will be lambda1, here wavelength of light lambda2. What about the frequency of light? Here f, here f. So this is the medium 2, medium 1. This will be denser, this will be rarer. Then what is the basic Snell's law? The Snell's law, what it says is like mu1 sine theta 1 equal to mu2 sine theta 2. As a denser, mu2 greater than mu1. What do you expect? Theta 2 should be less than theta 1. So this will become angle of incidence. This will be angle of refraction. This is the normal. This vertical line will become normal. And this will called as boundary or interface between the two mediums here. So what is theta 1? How you define angle of incidence? Angle made by the incident ray with the normal. Theta 2 is called as angle of refraction. Angle made by the refracted ray with the normal. All these angle in the Snell's law, these angles are measured with respect to the normal. So what do you mean by normal? So this is the boundary which will separate two mediums and a line drawn perpendicular to the interface. So boundary is called as a normal. And in the Snell's law, this theta 1, theta 2 are the angle of incidence and angle of reflection measured with respect to the normal. Okay, let's analyze here. Mu2 greater than mu1. So what do we expect? V2 less than V1. Lambda 2 less than lambda 1. Frequency of light is going to remain same. So when a ray of light moves from rare to denser medium, it will bend towards normal. And then can we get the deviation suffered by it? If there is no change in medium, it would have propagated this direction. So what is the deviation suffered by the ray? The deviation suffered by the ray is delta. So here can we just bring the deviation? So theta 2 plus delta equal theta 1. So deviation equal to theta 1 minus theta 2. Or angle of incidence minus angle of refraction. Should be the deviation suffered by the ray when it moves from rare to denser. Okay, now similarly, if a ray of light, if it moves from denser to rarer, then we'll see what conditions will arise. Okay, let this be the normal, not visible. Okay, let this be the normal. Now what is a boundary? There is a boundary. Now the ray of light is incident from denser to rarer medium. Now the reflected light will bend away from normal. This is the incident light. This is the theta 1. This is the angle of refraction theta 2. This is a refracted ray and this is a normal. Now, okay, I'll do one thing. Theta 3, theta 4 let me call. So this is a denser medium. This is a rarer medium. Here mu 3. This is mu 4. Here the wavelength of light lambda 3, speed v3, frequency f. Wavelength of light here lambda 4, speed is v4, frequency of light will be f. Frequency will not change as it propagates from one medium to another medium. Then again we'll apply the basic same Snell's law. What the Snell's law says is like mu 3 sine theta 3 should be equal to mu 4 sine theta 4. Mu 3 into angle of incidence sine theta 3 should be equal to mu 4 into angle of refraction sine theta 4. No, which is a denser? Mu 3 greater than mu 4, V3 less than V4, lambda 3 less than lambda 4. Then we'll go for the deviation suffered by the ray. What is the deviation here? The deviation will come. This is a deviation. So what is the deviation equal to in this case? The deviation should be equal to theta 4 minus theta 3. So when a ray of light moves from denser to rarer medium, the deviation will be angle of refraction minus angle of incidence. When a ray moves from rarer to denser, the deviation will be angle of incidence minus angle of refraction. Okay, like this, the primary conditions is what we define here. Now, why do the ray of light will bend? As already told you, the light wants to move from A to B. So it could have gone, so why it will not traverse straight? Again, it has to move from A to B in a shortest time. So therefore the light will bend here. It will move more in the rare medium than in the denser medium. To move between 2 points, if a medium encounters, like previous one, the light wants to propagate from A to B. Then it will prefer a path so that it can traverse in a shortest time. So therefore it has to propagate more in the rare medium than the denser medium. Based on this is what the Snell's law is derived, based on Fermat's principle. That only I'm just explaining through the diagrams here. The light moving from rare to denser. These are the 2 points. Why can't it just go straight? No. According to Fermat's principle, the light will propagate from A to B along a path which it takes the shortest time. So therefore, this is a path it will prefer. It has to propagate more in the rarer medium than denser medium. That's why it will prefer this path. Okay, this is about the bending of ray of light when it moves from rare to denser, denser to rare. So what is the conclusion? Ray of light bends towards normal of the refracted ray. The refracted ray bends towards normal when it moves from rare to denser. Same thing. The refracted ray of light bends away from normal when it moves from denser to rarer. Okay, now, so when a ray of light moves from rare to denser, it will bend towards normal. When it moves from denser to rare, it will bend away from the normal. Sir, okay, you are just showing it on like some diagrams you are drawn. Okay, Farmer's principle will agree it. Still, can you give a better explanation? Yes, we'll go for a better explanation. We'll